Okay, so I was going to use problem number 3 out of section 1.2, the differential equation y prime equals 1 minus y to the second power, and compare the results of the slope field with points from Euler's method. I'm using a Excel spreadsheet setup to calculate slopes for the slope field and the values for Euler's method. So I'm just starting from some random negative values so I can get values along these horizontal lines, -3, -2.5, because there are no x values. And I'm going by the steps for h equals 1/2. So I populate the y values, I populate the slopes, and then I can plot them on my directional field. So as you can see over here, for y equals 0, any slope along y equals 0 will give me 1. So I'll draw those on my slope field. Then you can also see that at y equals 1, the slope is 0. So I'll draw those slope lines. Those also would go in for any value on the horizontal line, y equals -1. If I look at -2 and +2, the slope is a steep -3. So I'll try and draw those in. That one's probably not quite steep enough. Okay. And so we're kind of seeing like a horizontal asymptote at 1 and -1. So I can trace in some solutions. So those would be possible solutions from my directional field or slope field. And so I did a similar thing to calculate possible points for Euler's method. So I'm taking smaller steps to try and increase my accuracy. H equals 1/10. And so you can see that the slope is exactly what I would expect at 0, 0 for an initial condition. And then I would have the computer populate y values, which aren't going to be correct until I get the slopes filled in. So the computer will also calculate these. All right. So I suppose we could estimate and see where these points are. So obviously it's 0, 0, and then it's about 0.5 and a little less than 0.5. Maybe right about there. I'm just going to stick with the first quadrant for now. And then 1. And then 1.5 and 0.9. And about 0.9, 2.5, about 0.9. So it looks like my curve from Euler's method would look like that, with a horizontal asymptote of 1, which is similar to what I got from the slope field or directional field.